Hello guys, what's up? Welcome to the channel King Coder. So today we are going to start a new topic on prefix sum. So what is a prefix sum and how we can approach a prefix sum? We will see it through an example. So the first example is find pivot index. Pivot index it is an index when left sum is equal to right sum in this question. So let's understand this with an example. We have this array, and if we find the left sum and right sum for any index, so what I can do, for index 0 the right sum will be the sum of all elements from the right of this position, and the left sum will be all elements from the left of this position. So left sum will be now 1 and right sum will be sum of all these number, that is equal to 28. Now this is the for index 0. For index 1 the left sum will be, for index 1 left sum will be 7 plus 1 8, and right sum will be 28 minus this one 27. For index 2 the left sum will be 8 plus 3 11, and right sum will be 27 minus 7 20. For index 3 the left sum will be 11 plus 6 17, and right sum will be 20 minus 3 17. So at this position 3 the left sum is equal to the right sum. So this condition is satisfying. Left sum is equal to right sum. So we will return this index. So let's see the pseudocode for this program. So we have traversed a for loop to traverse the whole array. We have taken left sum is 0 and right sum is 0. Now we have calculated left sum for 0 to that index, and we have calculated right sum from that index to the end of the array. In this case you can see the left sum will be 0 to 0, 0 to 0, and right sum will be 0 to n. So the left sum will be 0 to 0, and this is 0 to n. For index 1 this will be 0 to 1, and this will be 1 to n. For index 2 this will be 0 to 2, and this will be 2 to n, like this. Like this we can found the left sum and right sum. If this for loop doesn't get any kind of index, then we will return -1 at the last of the program. So this is the brute force approach. Let's look at the time complexity of this program. So time complexity will be big O of n square, as we have traversed a for loop, and in that for loop we are again traversing for the left and right. So this will be big O of n square, then space complexity will be big O of 1, because we have not take any kind of array. Now let's take a look at the better approach. So in the better approach, what we can do, we can take two array to store the left sum and right sum. So let's take two arrays called left and called right. That is two array. In this array we will store the left sum 0 1 2 3 4 and 5. This will be same as right 0 1 2 3 4 and 5, 0 1 2 3 4 and 5. So let's take a look at this array. So for this position 0, the left sum is, there is no element, so the left sum is 0. For this position 1, there is a element, that is 1, so left sum will be 1. For 3, for index 2 there are two elements. So how can we add these two elements? We don't need to traverse that two element. We can do that. For this 3 we can add a 7 to this one, so it will be 8. For index 3, we can add this 8 and this 3, so it will be 11. For position 4, we can add 6 plus 11, that is 17, and for position 5 we can add 17 plus 5, that is 22. To find the right sum, what we can do, we can start our traversing from the end of the array. So there is no element from the right of the 6, so that will be 0. For 5 there is a single element 6, so it will be 6. For 6 there are two elements, so as previous what we have done for the left array, we will do the add this 5 to this 6, so it will be 11. For 3 we will add this 11 and this 6, so it will be 17. For this 7 we will add this 17 and 3, so it will be 20, and for this one we will add 20 and this 7, so it will be 27. So you can see that for the 1 there is a right sum. So you can see that for the 1 there is a right sum that is equal to 27. For 7 there is a right sum that is equal to 20. For 3 there is a right sum that is equal to 17, and this is how it is working. You can see this for the left array as well. For 1 there is a left of no element, so it will be 0. For position 1, that is 7, there is only one element, that is 1. For position 2 there is only two elements, the sum will be 8. For position 3 there is a sum of 11, and so on. So if we traverse this left and right array, we can see that in this position 3 there is an element that is the left of I is equal to the right of I. So we can conclude that the position exists, the pivot index exists, and we will return that pivot index. So come to the pseudocode. What we have done is we have created a left array and right array of size n. We have initialized left of 0 with 0 and right 0. The right of n minus 1 is equal to 0, because we know that in the position of 0 there is no left element, so the left of 0 will be always 0, and the position for ARR of n minus 1 there is no right element, so that will also be 0. Now we have run a for loop to calculate the left array. So to calculate the left array, so left of I will be my left of I minus 1 is that element, left of I minus 1 plus nums of I minus 1, it means ARR of I minus 1. We have added this 1 and 0 and stored this in second index 1. So what we have done, we have done ARR 0 plus left of 0, and we have stored this value in left of 1. So this is the concept to calculate prefix sum for the left array. Same goes for the right of I, it means this part always 0, and so this, let's take this, right of I is equals to right of I plus 1, right of I plus 1 plus ARR of I plus 1. Now we have calculated the left and right both array, so we will check using this for loop. If right I equal to left I, we will return that I. If this is not happening, so it will return minus 1, so there is no pivot index, so we will return minus 1. So now let's take a look at the time complexity of this program. So time complexity of this program will be big O of n, and space complexity of this program will be big O of n. Time complexity is big O of n because there is no nested for loop. Here. We have run a single for loop for left array, single for loop for right array, and single for loop to compare. This is for left, this is for right, this is for compare. So the time complexity will be go up, and as we have created two 1D array, so the space complexity will be go up inside. Now let's take a look at the optimal approach. So in the optimal approach, we don't need to take two array for left and right. Otherwise, we can take two variables left and right. So let's take a left variable and a right variable. I am not gonna declare this variable now. I will see you the approach. So let's understand the approach. The approach is clear that for this position 0, my left will be always 1 and my right will be always the sum of all these elements. This is for the left and the sum is for the right. When we will go here, it means first position. My right will be sum minus nums of previous. My right will be sum minus nums of previous. I mean 28. So it will be 28 minus 1, 27. Yeah, it is perfect that the sum of all the elements from right of the 7 is 28. And what will be my left? My left will be this one. This one always be my left, and it will now add 7 also. So left will be my previous element, that is previous left, that is nums of 0 plus nums of I. So we can declare first that my left is always be nums of 0 for the 0th element, and right will be always my sum for the 0th element, and we will start our traversing from I equal to 1 to n. So for I equal to 1, my new left will be previous left plus nums of I, and my right variable will be previous right, let's say previous right, that is sum minus nums of I minus 1. As you can see here, for the 7, the right sum will be sum of all the elements minus this element. So this will be 27. This part will be 27. So this is for the right part. And we will check if left is equal to right, and we will return that index as we have done before. So let's see this pseudocode. In this pseudocode, in the first line, we have calculated the sum of all the elements in the array, and then we have declared the left variable as nums of 0 and right variable as sum. Now ignore this edge case for some time. We will talk about this later. Take a look at this traversal. We have traversed from 1 to n, as we have said that we will traverse 1 to n. We will increase our left value by nums of I. That is, you can see that left equal to left plus nums of I. And we will decrease the right sum value by nums of I minus 1, because we have seen that if this is the array, the sum of all these elements is 28, then sum of all these elements will be 28 minus this element 1. So this is my right. Now we are checking if right equal to left, then I will return I, otherwise I will return minus 1. So this will go from 1 to n. But what happened when the pivot index my is 0? So I is 1 to n, I am traversing, and I will find this between 1 to n only. So if my pivot index is 0, then what will you do? then we will check for this condition. Let's suppose this example. So in this example you can see that for 0 my left is 2 and my right is sum of all the elements, so it will be 2. So we need to check for this part. If left equal to right, then I will return that 0. So it will check for the only 0th index. Hope you understand this pseudocode, the optimal approach of this program. So now let's talk about the time complexity of this program. So time complexity will be big O of n and space complexity will be big O of 1, because there is no other array we have created only two variables. So these two variables, so the space complexity will be big O of 1 and we have traversed the array only one time, so the time complexity will be big O of n. So now let's try to code this. So you can see that in the code we have write the same thing. Sum is equal to 0. Now we have calculated the sum. Left and right initialized is arms of 0 and sum accordingly. Now we will check if the 0th position is my pivot position or not. After that we will traverse from 1 to n to find our pivot index. Left plus equal to nums of I and right minus equal to nums of I minus 1. So if it doesn't return any pivot index, so we will return minus 1, that is there is no pivot index. So let's run this code. As you can see, all the test cases are passed, so we will submit this. So I hope you understand this video. If you understand this video, please give a like, share and subscribe. If you have any kind of doubt, then please feel free to ask in the comment section. Thanks for watching.